Welcome to Belmont Journal. I'm your host, Jeff Hansell, and on today's edition of Belmont Journal, we're going to be talking to Andrea Daniele, and we're calling the segment Meet Your Neighbor, and here he is. Thanks for coming here today, Andrea.
Thank you for having me, Jeff.
Great. Andrea is somebody who's a resident of Belmont, and perhaps you've met him, perhaps you've not, but we thought after we got to know him, you'd like to know a little bit more about him. Now, how we got to know him here at the Belmont Media Center, his wife, Erica DeTuro, is a valued volunteer. She does editing and production around town, volunteers. Maybe some of you folks have seen her. And after getting to know her, we got to know Andrea and found out that he does some fascinating work in the world of robotics research. Is that right?
That's correct.
So what do you call yourself? We just had a discussion about that earlier.
Yes. Well, I'm a few things. So I'm a computer scientist, but I like robotics engineer better.
Okay. And of course, that is the thing these days, right? Everything is AI, robotics. So you're in the right field at the right time, right?
That seems right, yes.
Okay. And where are you folks from originally?
We're from Italy.
What part of Italy would that be?
From the south, from Calabria.
Okay. So is that like near the boot, as they say?
Yeah, that's the last piece of land before you jump off to Sicily. Yes.
And how long have you been here in Belmont?
In Belmont, about 3 years.
3 years, okay. And so going back to growing up in Italy, what is it? Was there a moment when you thought, okay, I want to be into robotics research, or was it something else that then led you to that?
Well, since I was young, I was very into computers. So I studied robotics engineer, and I got really passionate about computers. And then I went to Milan once, and I went to the Museum of Science and Industry.
Oh, is that a big?
Yes, that's the Leonardo da Vinci Museum in Italy. It's the biggest museum of science.
So it's a significant museum.
Yes, yes, it's the place to go if you're interested in science and industry. And so I went there, and there was a group of PhD students studying robotics, demonstrating robotics to. I was a kid at the time, and so there were a bunch of kids there playing with their robots, and they were teaching us about robotics, about things that you can do with robots. And so that's what it clicked. That's when I decided to.
I see.
To do robotics.
And when at that age, what were you thinking about doing when you thinking about robotics? Like, did you have in your mind something, what you would do with that?
Not really. At the beginning, it was just like, this is so cool, I have to do it. And I was close enough, studying computers, I was close enough to make the jump. But at the beginning, it was just like, this is so cool, I have to do it. And then eventually, I found my direction within robotics.
Did you have like a toy robot at home or something like that?
No, unfortunately. No, I only got to play with robots when I started my master's in Rome.
Okay. All right. Great. And then you came here and started working or started doing researching here?
I moved to the U.S. about 10 years ago to do my PhD. I was back in Chicago.
Okay.
Yes.
Do they have a good institute there for robotics
Yes,
research?
I was at the TTI Chicago. That's the Toyota Technological Institute at Chicago. It's one of the leading institutions in robotics and machine learning research.
Okay. Yes. Well, we're lucky to have you here in the United States.
Thank you.
So one thing that we talk about robots, but really, what is a robot?
All right, so let's see. So I believe we usually get the picture of a robot from science fiction movies, and we usually tend to imagine them as like the scary, big, powerful machines. Usually they look like humans, so they're humanoids. But really the definition of a robot is a lot simpler than that. It's really any machine that can do two things, can sense and can act in their environment. What does that mean is that that means that they can perceive the environment and they can somehow interfere with the environment.
Okay. So it could be any number of devices we have in our home as well.
Yes, funny enough, we have a lot of robots at home. We just don't know, like a fridge, for example.
Really?
That classifies as a robot because it can sense temperature in the fridge, and if that goes too high, then it turns on the motor to cool everything down. So it is a robot. And dishwashers and washing machines, they're also robots.
Let me ask a question that I may regret asking, but so robotics and robots, there's similar to artificial intelligence, or the two things that work together, because you have some refrigerators that can learn what you're taking out of the refrigerator and then tell you, oh, aren't you due to have an Aperol Spritz this time of day?
Yes.
Yeah.
You're right. AI and robotics, AI is the acronym for artificial intelligence, they tend to go together
Okay.
nowadays.
It's not exactly the same.
They're not exactly the
Okay,
same. No,
all right.
you can have AI without an embodiment. And so things like ChatGPT, that would be an example of artificial intelligence without a body.
Okay.
Like you interact with it through your computer. Robotics needs to have an embodiment.
Okay.
So you need to have a physical thing in the world. And then robotics uses a lot of AI to do the smart things that robots need to do.
So like a simple robot, people would have, well, it's not simple, but what's the device that can automatically vacuum your carpet?
Yeah, that would classify as
Yeah,
a robot.
right.
Yes, it has sensors, it has wheels. Yes, that's a
Right.
robot.
And a self-driving car is a little bit like a robot, but it's got a,
Well, that is exactly a robot. Yes,
That is
it has a
exactly
lot
a
of sensors, has a lot of cameras,
Okay.
and it can move. Yes, that's a robot.
and how do robots see and interact? I mean, there's a number of ways they do that, right?
Yes, there are different types of sensors that robots can use to perceive the world. There are LiDARs, basically systems that can measure distance to closest objects. The most common ones nowadays are cameras,
Okay.
and they're not any different from the cameras we have on our phones and the ones we have in the studio here. You just have a lot of them pointing in different directions.
So you're working on a robot now, right? A humanoid robot. We maybe have some video of that as well.
That is correct. Right now I'm working for Boston Dynamics, and I'm working on the Atlas project, which is a humanoid of Boston Dynamics.
And I think we're seeing some little video here now of what it's doing. That's pretty cool.
Yeah, so in the video you can see on the right-hand side the way the robot perceives the world. And so you can see that it's augmenting the image with things that you believe are of interest to the task that it's trying to perform. So you will see that it's going to drop some red dots and green lines in the places where it believes those are of objects or places of interest. And so what it's doing now, it was asked to look for objects that are misplaced on the floor,
Okay.
to identify them, to go fetch them and put them in the right place.
Wow. How long does it take for you to program something like that? Is it like trial and error? Takes months? What's the
Well, it really depends on the foundation that you have, like how much infrastructure you have, how good the engineers are.
Okay.
And at Boston Dynamics, we have a pretty capable team of engineers with a lot of years of experience in designing robot behaviors. So what we do there might be a little bit, it might appear simple.
Okay. But in any kind of robot, I guess what I'm saying is that you might be having different teams work on different aspects of that robot, the systems. Is that?
That is correct. Yes.
Yeah,
So,
or is there a lot of different ways that you can divide that project up?
yeah. So a robot is made of a lot of different parts. You definitely have the mechanical part, and so we do have mechanics
Okay.
taking care of the body itself, making sure that everything is ready and good to go. And then we have engineers working on behaviors. I'm one of them. I work in the behavior learning team. So my job is to teach Atlas
Okay.
new behaviors.
So you might want to teach you to do a particular thing, and then you would talk to the people working on the mechanical part to say, well, we need it to actually go a little bit over like this instead of, so they would use back and forth. It's an iterative process.
There is a lot. Yes, there is a lot of interaction between teams in trying to get the robot to do exactly what we want to.
And because you hear about it, but what's some of the most exciting things that are going on in terms of what you can enable a robot to do?
Well, allow me to take a little bit of a step back from what I do today. So when it comes to things that robotics and robots in general can enable, I believe the most exciting thing personally is the ability of robotics to accelerate space exploration.
Oh, really?
So I was fortunate enough to work on a robot about 3 years ago. It's a robot called Nui. It's developed by the Woods Hole Oceanographic Institution. It's just a few hours south of Boston in the Cape. And it's a robot that, developed by Hui, but supported financially by NASA. And the objective of NUI is to be able to explore deep sea under ice. And so it's interesting to go and see what's going on under the ice caps on Earth. But ultimately, the target is to go and explore other planets and moons that have liquid water. And so I believe the biggest development that is going to come out of robotics is really space exploration eventually. Wow. We're not there yet, but I think we're getting there.
You mentioned that you're sort of testing it underwater, right? But is there more that we can find that we're not finding through robotics undersea, underwater, or are we, in terms of that kind of area? Are there research going on about underwater exploration with robots, or is that?
Yes, there are a lot of projects that are going on right now. NUI is one of them, but there's many of them. And really, we're interested as a research community. We're interested in what's going on in the deep sea. We have basically no knowledge about what's going on in the deep sea here on Earth. But again, ultimately, we're interested, as a species, in exploring the outer space.
Now, it may not be your particular field, but I guess with the further you go down, obviously in the ocean, the higher the water pressure is, right?
Correct.
So you have to design robots that can withstand that as well, and the electronics work and everything else, right?
Yeah, so
that's got to be a challenge, right?
It is.
Yeah.
These robots are usually made out of titanium. And so yes, so you have to have in mind, you have to know what the depth of your deployment is before you start designing a robot. Yes.
So this robot undersea, the Hui, so you're thinking that we might send that to Mars or send a planet that has water? Is that?
Yes, so
that's one of the ideas anyway.
There is strong evidence that Europa, which is one of the moons of Jupiter, has liquid water underneath an icy crust. And I personally want to know what's swimming in that ocean. I don't know if you do,
okay.
But I definitely do want to know that. That's one of the reasons why I'm interested in robotics, because I see that as the true enabler to this kind of exploration.
Right. Yeah, so who knows, there might be life on Europa. Yeah, okay. And that does go, I see what you mean about, it's fueling your imagination because you're thinking about the movies that you've seen and saying, okay, and now you're really doing this. So it's sort of a realization of your dream, right?
That's right.
That's cool, okay.
Say that.
What do you think is the biggest misconception about robots that people have?
Well, again, going back to the way we usually formulate our pictures of robots, and it's usually guided by science fiction movies. And science fiction movies really like to depict robots that are evil and that eventually they're going to wake up and decide they're going to take over. But that is a big misconception about robots. Really, robots are not going to do anything that they're not designed to do or they're not programmed to do. So I don't believe at some point robots are going to wake up and realize that they can just take over unless we program them to, but we're not going to do that. And connected to that, I have another video that I want to share with you, and that is about a project that we worked on back in Chicago.
Okay, I think the viewers are seeing a little bit of that now, but go ahead.
And so at the time, we realized that the general public was really afraid of robots for no reason or for the reason we just mentioned. And so we wanted to build robots that would interact with the public and build trust, make it more comfortable. And so we built this robot, this robotic manipulator that can play checkers with kids. And so we took it to a museum, the Museum of Science and Industry in Chicago. And we had it for a weekend play checkers with young kids. And they got really comfortable with it, a little bit too much because they start leaning into the space of the robot. They got really close, but it was a great success. And we tried to do that in the past, try and build trust and build.
I see. Okay, right. So people getting comfortable with it, seeing how it works. Yeah. Okay. So that's fair. Yeah. And do you see in your own observation? I guess you see people getting more comfortable with that sort of relationship people have with robots.
And that's something that we're trying to do at Boston Dynamics as well. We're
Okay.
trying to change the mind, we're trying to change the idea of what robots can do.
Yeah, and it's already happening. So in a way, like, you might not be aware that you have a relationship with a robot, but you do.
But
and
you do,
this is
yes.
right. Yeah. So you've talked about your motivation and but is there anything else that drives you to work in this field? Is there any other, or is it just the fact that, there's untold sort of benefits to come in this kind of research?
Yeah, I believe that apart from the things that I mentioned before, like really as a true enabler to space exploration, which is something that I'm really passionate about, I really do believe that there's going to be a lot of things that robotics is going to bring, and we have no idea what that's going to look like.
Right.
The same way we had no idea what the airplanes
Right.
would allow us to do at the time
Yeah.
they were discovered, right? So yeah, I think that's that mystery around
Yeah.
robotics. That's also really exciting.
I know, and to digress a little bit, you've probably seen 2001: A Space Odyssey.
Yeah, of course.
I know when I saw it, it was like magic, but you realized, yeah, that is the future. That could be what the future is like, and it's pretty much like that in many ways. What they imagined. But what advice can you give to students out there who might be thinking about this and how to become a robotics engineer?
So robotics, unlike other fields, is not really tied to a particular subject. So you're not going to study robotics and that's it. It's really it's a field that touches a lot of different subjects. Like you want to have, as a robotics engineer, you want to have a strong background in computer science, in physics, in math, in statistics, in electronics. Of course, you're going to go and explore more in that one of these directions, but having a strong background in all of them is really a requirement to be able to work in robotics.
So it's not robotics for robotics' sake, it's robotics for some aspect of...
Correct.
Yeah, like yourself, you're interested in space exploration.
Right.
So.
Yeah. As an application, I'm interested in space. As a on an everyday basis, I work in computer science for robotics. So I focus more on computer science. But I can see the benefit of having knowledge in physics, in math, in electronics, and knowing how my code is going to interact with those components. Right. That's really important. And another thing that I believe is very important is access to mentorship. And so to young students out there who might be interested in a career in robotics, I would say talk to your science teacher because they can help you formulate a plan and how to get there.
Okay. And so maybe you can use robotics as a way to work in maybe something that you care about deeply. As well.
Right.
And so maybe that's good advice, because sometimes we just get wrapped up in the technology of it and what is it going to be doing, So, well, great. It's been fascinating to get to know you. I've known you for a while, and I learned a lot right here, and we hope you all did. This has been Belmont Journal, Meet Your Neighbor, and the neighbor we've been talking with is Andrea Daniele. He's part of one of the most involved, interesting couples in Belmont. Erica DeTuro is his wife, who you may see volunteering here, but we hope to see you back more often and give us an update on your research in robotics.
Thank you.
Thanks for being here. You've been watching Belmont Journal, and we'll see you next time.